Let's take a look at this problem. We want to verify the following identity. We got sine x over 1 minus cosine x is equal to 1 plus cosine x over sine x. Now I'm going to start with the left side, and the reason why is I recognize that this might be a conjugate problem. And that's whenever you have like a 1 and then a trig function in your denominator with a plus or minus between them. So I'm going to multiply by the conjugate. Now the conjugate is the first part's the same and the last part's the same. So I got 1 and I got cosine x, but the sign in the middle is different. This is a minus and this will be a plus. Now whatever we multiply by the bottom, we have to multiply by the top. So then that gives us sine x times 1 plus cosine x. And down below, the nice part about conjugates is all you have to do is multiply your first parts and your last parts. 1 times 1 is 1, minus cosine times cosine is cosine squared. Now whenever you see a number 1 and then a trig function squared, you think you're Pythagorean identities. And recall, we had sine squared plus cosine squared is equal to 1. And we want it to look like that. So I'd have to take the cosine squared and move it to the right side. So sine squared is going to equal to 1 minus cosine squared. So this becomes sine times 1 plus cosine all over sine squared. Now sine squared we can rewrite as sine times sine. When we do that, these signs are going to cancel. And we're going to end up with 1 plus cosine over sine, which is what our other side looks like. And that's our goal. We have to start with one side, manipulate it using our identities or algebra, and get it to look like the other side. Now we cannot touch the other side. We cannot multiply both sides by anything. You can only work with one side in terms of verifying identities, because we're assuming that this is not true. We're trying to verify that. If you multiply both sides by something, you're assuming that that's true.